There is a man in this painting holding a jar, and for more than a century, almost everyone who looked at him got him wrong. He is standing on the front of a wooden sledge. Behind him sits a stone figure taller than a two-story house. In front of him, 4 long rows of men lean into ropes, and he is tipping liquid out of that jar onto the ground, right onto the strip of sand the sledge is about to slide across. For generations, the explanation was the same everywhere you read it. A blessing, a ritual gesture, sacred liquid poured out before a holy object moves, symbolic, decorative, meaningless to engineering. Then, a team of physicists filled a tray with sand, built a small sledge, and dragged weight across it while machines measured exactly how hard they had to pull. Dry sand failed. The grains piled up in front of the sledge into a growing wall, and the harder they pulled, the bigger that wall became. Then they wet the sand, not soaked. A few percent water by volume. The grains locked together, the surface went stiff and flat, the wall stopped forming, and the force required to drag the load collapsed to half of what it had been. Half. Not a small improvement. Half the crew, half the rope, half the time. The man with the jar was not praying. He was running the machine. That result was published in Physical Review Letters in 2014 by a group led by Daniel Bohn at the University of Amsterdam. And the sweet spot they measured was narrow, somewhere between 2 and 5% water, depending on the grain. Too dry and the sand heaps. Too wet and the surface turns to soup and the sledge sinks. There is an optimum stiffness, and hitting it is not luck. It is a technique that has to be learned, taught, and repeated across a work crew for hours at a time, under load. The painting is from a tomb at Deir el-Bersha in Middle Egypt, roughly 320 kilometers south of Cairo. It belonged to a provincial governor named Jehutihotep, and it was carved around 1880 before the Common Era. The scene shows the transport of his own statue. Count the figures on the ropes, and you get 172 men. That number is where the story stops being a nice piece of trivia and starts being a problem. Because the statue in that painting is estimated at around 60 tons, run the arithmetic on 172 men pulling a 60-ton load across wetted sand, and the numbers just barely close. They work, which means the wet sand trick, the one that made headlines around the world as the answer to how Egypt moved its stone, is only enough for 60 tons on flat ground, with a full crew on a prepared surface. And Egypt did not stop at 60 tons. 900 kilometers up the Nile at Aswan, there is an obelisk still lying in the granite bedrock where it was cut, abandoned when a crack opened along its length. Finished, it would have weighed somewhere near 1,090 tons. On the west bank, at Luxor, 2 seated figures of Amenhotep III weigh roughly 720 tons each. And the quartzite they were cut from comes from a quarry near modern Cairo, 675 kilometers away. Inside the Great Pyramid, the ceiling of the burial chamber is made of granite beams, the heaviest estimated near 80 tons, and they are not sitting on the ground. They are 43 meters up, in the middle of a solid mountain of masonry, above 4 more stacked layers of the same granite. 80 tons, lifted the height of a 14-story building, 4,500 years ago. So water on sand is real, it is proven, and it is nowhere near the whole answer. There are 3 more pieces, and each one has been sitting in the archaeological record for years without ever getting the attention that one painting got. A road, older than every other road on the planet. A logbook written by a man whose actual job was hauling stone. And a set of holes cut into rock at the edge of a quarry, which one archaeologist described as a system that has never been found anywhere else on Earth. Put them together and you do not get a mystery. You get a method. And the last piece of that method suggests something that sounds impossible until you look at where the water went. Start with the ground, because everyone starts with the stone And that is the wrong end of the problem. Out in the northern Fayum Desert, north of Lake Karun, there is a line running across the landscape that most people would drive straight over without registering it. It is about 2 meters wide. It is buried in places, exposed in others, and it runs for roughly 11.5 kilometers from a set of basalt quarries down to the shore of a lake that no longer exists. It is the oldest surviving paved road in the world, roughly 4,500 years old. Older than the wheel had any practical role in Egyptian construction. Older than Rome by 2,000 years. And it is not a track worn in by traffic. It was built. The base layer is slabs of sandstone and limestone. On top of that, irregular pieces of basalt. And something stranger. Logs. Black, dense, unmistakable logs of petrified wood hauled up from the fossil forest nearby and laid into the surface. The purpose is not decorative, and it is not ceremonial. It is to stop a loaded sledge from sinking into desert sand. That road, documented in detail by teams including Elizabeth Bloxham of University College London and the geoarchaeologist Per Stormare, ends at a quay near an Old Kingdom temple called Qasr al-Saga. The quay sits at an elevation that matches the ancient high water level of Lake Moeris, 22 to 23 meters above sea level. Basalt came out of the quarry, went down the engineered road on sledges, was loaded at the quay, and then floated on water into the Nile system and onto the pyramid fields at Giza, Saqqara, and Abu Sur, where it became the black paving of temple floors beside the pyramids of Khufu, Userkaf, Sahure, and Nuseri. Read that sequence again because it is the actual answer hiding in plain sight. The overland distance was 11 kilometers, the water distance was the rest of the journey, and it was the bulk of it. They did not move heavy stone across Egypt. They moved heavy stone across the shortest possible strip of prepared ground, then handed it to a river, which reframes everything about the sledge. The sledge is not the transport system. It is the loading dock. And this is where the mythology of it all starts to come apart in a useful way. The Egyptians described their monuments in language that sounds like theology. Stones that rise to the horizon. The lake of the king. Offerings poured before a divine image. For decades, scholars read those phrases as devotion and moved on. But the lake of the king turns out to be a harbor basin. The poured offering turns out to be friction control. The stone rising to the horizon turns out to be a construction site with a delivery schedule. Not a myth, not a metaphor, a logistics network described in the only vocabulary they had. Here is where it gets strange, and here is where we start to catch the people running that network in the act. In 2013, a French mission led by Pierre Tallet of Paris Sorbonne, working with Gregory Marward, was excavating a site called Wadi al Jarf on the Red Sea coast, about 180 kilometers south of Suez. It is the oldest known harbor complex in the world, a set of galleries carved into limestone hills where boats were dismantled and stored between voyages. In front of those galleries, buried among blocks, they found papyri. They are the oldest inscribed papyri ever recovered in Egypt. They date to the 26th year of the reign of Khufu, the pharaoh who built the Great Pyramid, which means these documents were written while that pyramid was being finished. And they are not religious texts. They are timesheets. The best preserved sections are the working diary of a middle-ranking official named Merer. Merer was an inspector. He ran a crew of around 40 men. One unit inside a larger gang of roughly 160. And that gang had a name that sounds like a ship's name, because it was 1. A formation called the Escort Team of the Serpent of Khufu is its prow. Merer's job was boats and stone. His diary records, day by day, in 10-day working cycles, the movement of white limestone from the quarries at Tura on the east bank to the construction site at Giza. He notes loading. He notes sailing upriver and downriver. He notes where he spent the night. He records deliveries to a destination the text calls Akhet Khufu, the horizon of Khufu, understood to be the Great Pyramid itself, and to a second place called Ro She Khufu, which translates roughly as the entrance to the basin, or lake, of Khufu. That second name is the important one, because Tura sits about 17 kilometers from the Giza Plateau, and the Nile today is several kilometers away from the pyramids. If Merer was delivering stone by boat, the water had to come to the pyramids, and a basin with a name and an entrance is not a poetic flourish. It is infrastructure. For years, that was an argument championed most persistently by the archaeologist Mark Lehner, who had been mapping the settlement of the pyramid workers on the plateau, and arguing that a harbor complex sat at the foot of the site. Then, the sediment settled the argument. In a study published in the Proceedings of the National Academy of Sciences in 2022, a team led by Haider Sheisha analyzed cores drilled from the floodplain east of Giza, reading the pollen and sediment layers like a chart of water levels going back thousands of years. They found the ghost of a former arm of the Nile running past the plateau, now called the Khufu branch. It stood high during the reigns of Khufu, Khafre, and Menkaure, exactly when the three Great Pyramids went up, and it declined afterward. The river was there, the basin was there, the boats were there, and we have the paperwork. If you want more investigations that follow the physical evidence instead of the folklore, subscribe, because this channel exists to chase exactly this kind of paper trail. So now the picture has changed shape. Water is not one trick in this story. Water is the entire transport spine of the Egyptian state. Stone floats to within meters of the site during the flood season, when the river is high and heavy hulls can reach places that are dry desert for the rest of the year. That is why the diary tracks the calendar so obsessively. That is why Merer's stone runs come after the water rises. But floating a block to the base of a plateau still leaves you with the problem that no boat solves. You still have to get 80 tons of granite up. And for 150 years, the answer to that was a shrug wrapped in a diagram. Ramps. Everyone said ramps. The trouble is that a ramp gentle enough for a heavy sledge at the shallow gradients engineers assumed were necessary would have to be enormous. Some reconstructions required a ramp with more material in it than the pyramid it served. So the ramp theory kept getting redrawn, and none of the drawings had physical evidence attached. No one had ever found an intact stone hauling ramp with its working parts still in place. Until 2018, at a place called Hatnub. Hatnub is an alabaster quarry in the eastern desert, about 65 kilometers southeast of the modern city of Minya. It is remote, it is hot, and it is one of the best preserved industrial sites in Egypt. A joint mission from the French Institute for Oriental Archaeology and the University of Liverpool, co-directed by Yannis Gordon and Roland Enmarch, had been working there for years, recording more than 100 inscriptions left by quarrying expeditions and mapping the stone huts where the workers lived. Then they uncovered the way the stone came out. It is not a gentle ramp. It is a central ramp and cut into the rock on both sides of it, a staircase. And along both staircases, running the full-length post holes, sockets cut to hold heavy wooden posts. Gordon's reading of it is direct. A block goes onto a sledge on the central ramp. Ropes run from the sledge out to the posts on either side and back. Teams stand on the steps, not on the ramp, and haul. The rope, wrapped around a fixed post, becomes a force multiplier, the same principle as a capstan or a pulley, without needing a machined wheel to do it. And with that arrangement, they were pulling multi-ton alabaster blocks up gradients of 20% or more. 20%. That is steeper than almost any road you have ever driven. That is steeper than the gradients the standard reconstructions assumed were physically possible with a sledge. The mission dated the system by the tool marks and by 2 inscriptions of Khufu found at the site, which puts this technology in service during the reign of the man who built the Great Pyramid, at a quarry supplying his projects. Gordon's comment on it was blunt. This kind of system he said, has never been discovered anywhere else. Think about what that sentence actually means. The one intact stone hauling machine ever found in Egypt from the exact rain in question uses a method that appears in none of the standard textbook diagrams. Which raises an uncomfortable question. If the only surviving example is something nobody predicted, how confident should anyone be about the ramps they have been drawing for the last century? And Hatnub is not the only place the ground remembers. At Lisht, further north, the excavator Dieter Arnold documented construction roads and ramps built of mud brick with wooden beams laid crosswise into the surface. The same idea as the petrified logs in the Fayum Road. The same idea as the wet strip in front of Jehutihotep's sledge. Prepare the surface, reduce the friction, multiply the force at the rope. And we are not guessing about the hardware, because some of it survived. Heavy wooden sledges have been recovered from Egyptian sites, thick runners with rails and slots cut for lashings, sized for real loads, and worn down where the rope bit into them. Coils of ancient rope have come out of the same desert galleries where the Red Sea papyri were found. Some of it still holding its lay after 4,500 years. Wooden levers, copper tools, sledge runners, rope, rollers, and a prepared surface. That is the entire toolkit, and every part of it has been dug up. None of it is magic. All of it is engineering. And every single piece of it involves controlling the interface between the load and the ground. That is the third clue, and it sets up the one that is genuinely hard to sit with. Because there is a difference between reducing friction and defeating gravity. Everything so far explains horizontal movement and steep hauling and river transport. None of it comfortably explains the granite 43 meters up inside the Great Pyramid. And none of it explains the strangest architecture in Egypt, which happens to be the oldest. Go to Saqqara, to the Step Pyramid of Djoser, built around 2680 before the Common Era. It is the first monumental pyramid, the first structure in the world built entirely of dressed stone. And its architect, Imhotep, was still being worshipped as a god 1,500 years later. Everyone photographs the steps. Almost nobody looks at what surrounds it. A few hundred meters to the west sits a colossal rectangular stone enclosure called Gisr el-Mudir, big enough to hold several football pitches, first described by Europeans in the 1700s, and never satisfactorily explained. What was it for? It has no obvious tomb, no obvious temple, no obvious purpose. Around the pyramid itself, there is a huge trench called the Dry Moat, divided along one section into a series of deep compartments, also unexplained, and inside the pyramid, there are two large vertical shafts, one of them running right up through the structure, with granite chambers near the bottom and stone plugs. In August 2024, in the journal PLOS ONE, a team led by Xavier Landreau of the CEA Paleotechnic Institute in France published an interpretation of all of it at once. Their reading is that these are not four separate mysteries. They are one system, and the system is hydraulic. Gisr el-Mudir, they argue, has the profile of a check dam, not a wall for show, a wall built across a watershed to catch flash floodwater coming down the Abusir Wadi and trap the boulders, trees, and heavy sediment that come with it. Downstream of that, the compartments of the dry moat function as a settling and filtration cascade, water passing from one basin to the next, dropping its silt at each stage, coming out the far end clear. Clear, because a hydraulic system full of sand destroys itself. And then that clean water, in their model, enters the shafts. A massive wooden float sits above the granite chamber. Ropes from the float run up over supports at the top of the shaft and down to a lifting platform. Water rises, the float rises, the platform carrying stone rises with it, straight up through the middle of the structure. They describe the blocks emerging from the center of the pyramid in what they call volcano fashion. A water-powered elevator inside the oldest pyramid in Egypt. Sit with the implications for a second. Not aliens. Not lost super technology. Buoyancy, rope, and a controlled water supply, which are precisely the three things Egyptian engineers demonstrably mastered better than anyone else in the ancient world. They built canals, they built barges that carried 1,000-ton monoliths. They spent their entire civilization managing the annual rise and fall of a river with life or death precision. The proposal is not that they invented something alien. It is that they pointed the skill they already had upward instead of sideways. And if that is what those shafts are, then the reason nobody recognized them for 200 years is embarrassingly simple. We were looking at a machine and calling it a tomb. Now, does this prove that Egypt had a hidden lost technology that mainstream archaeology is refusing to acknowledge? No, it does not. And the honest version of this story has to say so. The hydraulic lift paper is a hypothesis, and it has taken real criticism from people who know Saqqara intimately. The Egyptologist Kamil Karaskovich has pointed out that the lake the model depends on appears in no ancient Egyptian record and may never have existed at all. Other specialists have argued that Jizr el-Mudir is more plausibly an early experiment in the giant stone enclosures that later surrounded royal burial grounds, and that occasional desert rainfall in that watershed could not have supplied enough water to run a lift for the years a pyramid takes to build. Landro's own team acknowledges that more work is needed on how much water was available and how it moved through the shafts. The same caution applies down the line. The wet sand experiments were done in a laboratory tray at pressures of the same order as an Egyptian sledge, but not identical. The Hatnub post-hole system is documented at one quarry, hauling alabaster, not at Giza hauling granite. The Khufu branch of the Nile is real, but the exact position of a harbor wall is still being argued about. So here is the grounded version, and it is not a letdown. It is better because all of it is evidence-based. There was no single lost secret. There was a stack of ordinary techniques applied with extraordinary discipline. Cut the stone as close as possible to a waterway. Build a purpose-made surface for the overland leg, and keep that leg short. Wet the sand to the exact stiffness that halves your pulling force. Put the load on a sledge that spreads the weight. Run the ropes around fixed posts so a team on a staircase can outpull gravity on a 20% slope. Time the whole operation to the flood so the river comes to you. Dig basins so the boats can unload where you actually need the stone. And organize thousands of people into named crews with inspectors and 10-day work cycles and written logs. So the entire thing runs like a supply chain instead of a mob. That is the lost method, not a machine, a system. And the reason it looks like a mystery is that almost every component of it was made of water, wood, rope, mud brick, and sand, which means almost every component of it rotted, drained, or blew away, leaving only the stone behind to be admired by people who assumed the stone was the hard part. For a sense of just how good that system was, compare it to what came after. In 1586, the architect Domenico Fontana moved a single Egyptian obelisk of roughly 330 tons across a few hundred meters of ground in Rome. He had iron, he had compound pulleys, he had capstans. He had centuries of Roman and Renaissance engineering theory behind him. He needed around 900 men, 75 horses, 40 winches, and months of work, and it was considered one of the great engineering achievements of the age. The Egyptians had moved stones twice that weight, hundreds of kilometers, with rope, timber, sand, and river water, more than 2,000 years before Rome existed. Which brings us to the part of this that should actually make you angry. The physical evidence for how they did it is not protected. That 11.5-kilometer road in the Fayum, the oldest paved road on Earth, the one with the petrified logs still black in the surface, was nominated for World Heritage status in 2003. Researchers who worked there described it as a site that offers insight into the enormous feats of stone transport of the Pyramid Age. The nomination went nowhere. And while it sat in a file, modern commercial quarrying moved in on the same basalt. Photographs of the quarry landscape taken in 2001 show it essentially intact. Photographs taken 5 years later show sections of it gone, bulldozed for aggregate. The oldest road in the world, partly destroyed for gravel, while the paperwork waited. Nobody classified it, nobody sealed it, nobody had to. It was simply ignored until pieces of it stopped existing, and the desert is quietly finishing the job. Every year, the sand advances a little further over the ruts left by sledges hauling stone for Khufu's temple floors. So what would it mean, all of it together, if the full picture is right? It means the pyramids are not evidence of lost knowledge. They are evidence of lost infrastructure. It means the achievement everyone marvels at was not a secret held by a priesthood, but an industrial civilization built on hydrology, running on a river that no longer flows where it flowed then, with harbors that are now farmland, canals that are now dust, roads that are now being crushed into aggregate, and lifting gear that was made of wood and therefore vanished within a century of its last use. It means we have been staring at the output of a machine and mistaking it for a monument. And it means the ancient descriptions everyone treated as superstition were closer to accurate than the modern reconstructions that replaced them. When the inscriptions talk about the Lake of the King, there was a lake. When the painting shows a man pouring liquid before a sledge, he is doing the single most important job in the procession. They were not mystifying their work. They were recording it. We were the ones who decided it was poetry. Which leaves one question that nobody can answer yet. If the shafts under the oldest pyramid in Egypt were built to move water and lift stone, then there are structures at Saqqara, at Giza, at Dashur, and Abu Sir that have been cataloged for 2 centuries under a single word: tomb. Chamber, shaft, enclosure. Labels applied by people who assumed that everything an Egyptian built was built for the afterlife. How many of them are actually machinery? The shafts are still there under millions of tons of stone. The trench is still there. The great enclosure nobody can explain is still sitting in the sand a few hundred meters from the most photographed pyramid in the world, and almost every visitor walks straight past it. The permits for the excavation that would settle it have not been issued. The nomination for the oldest road on Earth is still unresolved, and the sand keeps moving. Somewhere out in the Fayum, there is a 2-meter wide line of stone and fossil wood running toward a lake that dried up thousands of years ago. If you stand on it, you are standing on the surface of the machine. And the men who built it left the instructions where nobody thought to look, in a painting of a man holding a jar. If you want to see how deep the paper trail goes, the next investigation is on screen now.